the world with CIB, as well as world membership for CIBSE. So this afternoon, we're going to address the exciting things about the fourth industrial revolution. And some of you will be aware of the book by Schwab, who was co-founder of the Economic Forum in Davos. Excellent book on outlining the future in terms of the short term, the medium, and long term. So this afternoon, we've got 4 speakers. And to begin with, I'd like to introduce Philippe Ross, who's the Chief Executive Officer for Unwired. So over to you, Phil.
Derek, thank you. Right, I will share screen. It's, can I share screen, Derek? Is that yeah, there we go. So is that appearing on everyone's screen? Can someone just give me an affirmative that that's
That's it.
Yep. Fantastic. Well, look, it's a pleasure to be here virtually in these strange times. But I guess, as Derek has said, my brief in about the first 15 minutes is to give you a flavour of intelligent buildings and the kind of how they're shaping the new world of work. And I guess I started off with this kind of fairly interesting image from an artist about the kind of the drudgery of most people's existence from desk to door and door to desk, and how much it's unintelligent. So our starting point really is the kind of dumb building which most people inhabit today. I think really when you think about the new world of work, you need to think about how it's envisioned. And to me, it's not about physical space. It's about people and how people will work in the future. So we like to start down here with people. We like to then overlay that with digital disruption, and then think about buildings and workspace, and the idea that the future of work will be defined by very different approaches to all 3 of those areas. It touched on what I call the 8 forces that are reshaping the world of work. And so very briefly for you, it really starts with the organizations that inhabit those buildings that we create. And they're changing dramatically. The first 3 jelly beans, and we have a philosophy called jelly bean working, touch on the new vision and values they have, the management styles and behaviors, the people they want to attract, and the experience they want to get for those people, the organizational design that they want to look at, the technology they're deploying for infrastructure for end users, where they are in the city, how sustainable and smart they are, which is the focus of today's short talk, the brand, the narrative, the experience they want people to have coming into their space, and then finally the workspace. And I guess we're talking in very interesting times, right? COVID has redefined what the future of work and the workplace could look like. And we are predicting now a 30 to 40% reduction in the need for real estate with a post-COVID view of the world of work. And that's reinforced by many others. McKinsey have just put out a paper recently talking about a 30% reduction in real estate as a result of changing the way we work in a post-COVID world. So very briefly, as Derek said, I founded the business 25 years ago. Actually, Unwired is at the centre of a couple of firms. And really, Unwork I'm talking about Unwork, our consulting business, which looks at innovation in the built environment and the future of work. And as part of what we do, we have an academy run by Professor Jeremy Myerson. So we're very steeped in learning and academic research as much as consultancy and practice. And I think the journey starts really with going backwards. I like in Unwork to unbundle and unravel where we start from. And really, the journey begins where we started. We came into buildings, we sat behind desks. And really, by and large, those people who sat behind those desks were not very engaged. Gallup produce a wonderful survey every year of engagement of white-collar workers in North America. And the vast minority of people are engaged at work. Most people turn up and they don't really want to be there. And I think pre-COVID, we were making our spaces more and more dense. We were cramming more and more people into less and less space, really because space was expensive. And therefore, a lot of architects and facilities and real estate people said, well, let's just get more and more people into that space. And I've seen space standards down to 60, 70 square feet per human being. But we're seeing now organizations say, well, let's think differently about the future. Let's be a bit more unconventional, perhaps a bit more uncorporate about what we need. And much of that starts with the organization itself, as I mentioned on those 8 forces. McKinsey and many others talk about the idea of an agile organization. Now, what does that mean? I mean, this is McKinsey's definition. You know, agile organizations are, they're obviously different. They're built around teams and networks, as opposed to the traditional organizations built around static, siloed, structural hierarchy. And typically, if you projected the org chart onto the side of a building, that's how we work today. People sat in their departments, coming endlessly into meetings because they're all sat separately when they're trying to work in teams and projects. So we think things are going to be very different in the future. It starts, to my mind, with the idea of the next generation. And if you look at those, what I will call the digital dependents, the Gen Zs, we think they'll expect a digital workforce and a digital workplace and a digital workplace experience. Yeah, I won't ask on a VC, but I guess anyone know what this is? If anyone's not on mute, I'd be impressed if someone could shout out what that is. But as I guess most are muted, this is Fortnite, right? Which many millions of people are playing. And if you have a 16, 17-year-old, 14, 15-year-old, they'll be on Fortnite, as they will be on Snap and Insta, as they say. When I'm doing focus groups with the classic 15-year-old, they use Snap Maps, and they just see where all their friends are in real time and what they're doing, and they have no issue with privacy. They expect on their cell phone, which is the kind of pivot to their world, to see everything. So we think as they come into the workplace, they'll expect to use that same cell phone to experience a digital building. The technology is fascinating. I could spend a long time on this, but just to give you a flavour, there's so much going on. You know, when you look at the pivot of the cell phone and you see how spaces in Asia, in the public realm, are already changing based on behaviours, you overlay that with the Internet of Things, which really allows the inert to be connected, and you begin to think about the sensors and the cameras coming into our physical spaces to understand what's happening inside them. And the early innovators, you know, the retailers who are saying, well, now we can track people and know who they are. We can challenge and change retail forever. What does that mean for buildings? Well, straight away when you come in, you can have a different experience. You know, if you can log into your phone with your face and enter a country with your face, why can't you enter a building with your face? And I love in the bottom right, Alibaba's new Smile to Pay in China, where it checks you out with your biometrics, but won't cash you out until you smile. So, you know, a bit of happiness in retail. But while there's often a rush in projects, in fit-outs, to put in sensors in ceilings. So, for example, if you want to measure the occupancy of meeting rooms, the first knee-jerk reaction is let's put sensors up on the ceiling or in the lights or above the door. Well, actually, let's be more pragmatic, because the average meeting room has VC equipment, which has cameras, and the cameras can see what's going on. So a camera on a VC unit from Cisco, Huddley and the like can count the number of people in the room very quickly, but they can also tell you who they are, and therefore using AI tools they could tell you what technology they're using in the room and how engaged they've been. And as I mentioned in a minute, you know, quite soon with voice, you know, if John on the left hand side has been to the last 10 meetings and has said nothing, it might prompt someone to say, well, should you have been there? So the data that these sensors are generating and the systems such as cameras and the like is immense. And I think in a smart, intelligent building, not only must they be analysed, but presented back to people, to different audiences. So we're seeing around the world all sorts of innovations. This is what I would call an information radiator. And here at Deloitte in Toronto, you're really sharing with clients and other employees and other visitors how the building is performing. And that keeps changing and refreshing with a whole range of data sets. So my gut feel is once you know the dashboards you want to make decisions, to share knowledge, to make people more effective, you can then work out, well, where does that data come from? And therefore, what sensors and sources of data do you need in the intelligent building to enable that? Once you have this in place, of course, you can then put the experience into people's palm of the hand with their mobile phone. You can allow wayfinding, because these systems know where you're standing down to quite a lot of granularity, a few inches, and where you want to go and where your colleagues are. And so most of our clients are beginning to actually implement very advanced apps for that workplace experience all over the world, helping you find things, know what's near you, find the next available, and more about well-being. You know, if you've been sat down all day, it might nudge you to move. So we have this vision of a value scale for smart buildings, as Derek said, you know, intelligent buildings. And it starts at the bottom where we are familiar with energy savings, but it heads up the value chain, past kind of personalization and contextualization into sentience. You know, how do we feel? And eventually using AI tools, algorithms, deep learning into the idea of predictive analytics, predictive nudges, shaping behavior and making suggestions. And as we know, we think Wired was probably the first around data being the new oil. This is fundamental. But the journey gets more interesting still. You know, when you look at what's going in the labs of the tech firms, it's really intriguing. So we think voice is coming to smart buildings. Amazon has got Alexa, as we well know, and there's Alexa for Work coming. Microsoft has Cortana. Cisco has just bought Voicea. The ability to use voice to start meetings, to order things, to request heating and ventilation changes will be remarkable, with obviously huge impact on integration into BMS and other systems. Coming soon as the robots. We're talking about, you know, the fourth industrial revolution. There's a huge amount of innovation around robotics. We're seeing it first in retail, in hotels, but what does that mean for all types of the built environment? You know, how will robots function? How will we also, given we can be more and more virtual and COVID's imposed this mass adoption of remoteness, how can we also think about immersion and being able to be augmented or virtual in reality? And that touches on this idea of digital twin as well. How can we begin to model the physical world with a digital twin of that and allow us to both optimize it and track it and focus on the experiences that we want it to bring? Many other things we think are coming, you know, drone ports, transport systems, no longer on the ground level, but could be higher level in buildings. So we're seeing that the entrance kind of moves from the ground floor plane to different levels of buildings, and we are seeing deliveries coming potentially into drone ports at different levels. So these kind of are major shifts, right? These are challenging the nature of what kind of buildings we want. And they're all led by occupiers. You know, the fact I mentioned earlier that McKinsey and Unwork is suggesting 30–40% reduction in requirements for space means that the space we need should and could be different. So when we do go to the workplace, there must be a purpose behind it. And therefore, it's not just about going to a desk and doing what we're now all doing from home, or using a meeting room when that may be a challenge, but about the activity, the task we're trying to do. And therefore, we're seeing the amenities needed inside buildings being very different. And I know Matthew's speaking after me, but we were lucky to, both of our firms help shape 22 Bishopsgate, which is the new tower by Sir Stuart Lipton being developed in the city. And that's been a fascinating journey. And Sir Stuart had a fascinating vision around making this the smartest building, certainly in London, if not in Europe, with a huge amount of ingredients that went into this. For example, when you now come into reception, there is full biometric access. But the smarts were integrating 4 aspects of that entry experience. So the Ionics biometrics were integrated with a Chubb security system with Booney gates and Otis elevators to give you a completely seamless experience. And of course, we did that pre-COVID. But now, you know, the idea of a touchless experience coming into a building and getting into a lift and going to your floor is real and desired. And if only we had smart buildings, it would be a lot easier to get back into the workplace. So 22 is going to have completely smart infrastructure throughout. It's enabled by an app that brings that all together. And as I mentioned, it brings together a community of people who share all of those blue coloured levels, where there's going to be great food and drink offers from Rhubarb, incredible leisure and gym from BXR, a whole hospital on one of the floors for healthcare provision, and even Convene taking a number of floors to provide you with meeting spaces, auditoria, clubs, etc., etc. So a tenant now taking a smaller space on a floor can then share amenities. So I think a lot about the smart building of the future is about the sharing economy and how we can use that intelligence, the app, to provision that in an intelligent way. So that's an exciting building coming to London, which I think will set new standards. So finally for you, 7 takeaways to kind of close this short presentation. To us, there's a number of elements of a smart building. I mean, it's about experience and people. So that needs to be enabled probably through an app, but other things as well. To be smart, it should be cloud ready. And with that should come resilience and better infrastructure as people carry what's called their endpoint, their portable device, and just need to connect up to the cloud. It should offer you ambient intelligence, knowing who you are, where you want to go. And out of all of that comes big data and the analytics you can drive through that. You can activate the building now. It doesn't need to be this inert space, but it can change and react to the people in it. And you can obviously offer shared amenity, the idea of something like workplace as a service. And finally, it was interesting, one of my clients said to me recently, could somebody arrive at work, spend the day in a building and leave healthier than when they first got there? And of course, given COVID and all the other kind of concerns, a smart building needs to provide not just sustainability, but a healthy, well environment for its people. So that's a very brief, Derek, opener for you, but just to hopefully share a few ideas as we emerge into this new pandemic-free world.
I think you're on mute, Derek.
Hello?
There we go, we've got you.
All right, okay. Thank you, Phil. Sorry, repeat my point. Thank you for that excellent presentation. And those 7 takeaways are absolutely fundamental, I think, and hit the spot right. Now we're going to move to a paper by Matthew Mulson, who is also going to introduce his other remaining speakers. And I'll come back to you when it's time for questions. Over to you, Matt.
Lovely stuff, thank you. Can you see that?
Yeah.
Oh, good, thank you. And thank you, Phil, for that presentation. So I'm Matthew Mulson, Head of Smart Places at the Engineering Design Consultancy, WSP. And some of the things that we've been working on more at the sort of city scale of late is looking at how the technologies of the 4th Industrial Revolution will have some kind of impact on the built environment and fundamentally to some of the design work that we've got going on. So as Derek mentioned at the start, the brilliant couple of books by Klaus Schwab, who says the 4th Industrial Revolution represents a fundamental change in the way we live, work and relate to one another. It's a new chapter in human development enabled by extraordinary technology advances commensurate with those of the 1st, 2nd and 3rd Industrial Revolutions. These advances are merging the physical, digital and biological worlds in ways that help create both huge promise and potential peril. So when I'm trying to break this down for some of our clients, I use my 4th Industrial Revolution splat, and I've kind of picked out 10 technologies that I think will have the biggest impacts to us as designers and people that are involved in the built environment. So I've picked out for each one of these a couple of examples around what we're seeing going on. So to start with, if we look at bioengineering, this is kind of everything to do with how we can augment the human. For instance, as somebody that works on site, is it about wearing a set of robotic arms that can help you lift heavier loads, or in the same way that you might in factory situations work with robots to do things, or am I already an augmented human because I wear contact lenses? For one of our clients in the Middle East, we've actually been looking at neurotechnologies so that there are some thought control that's going on for some of the staff in a security context for an airport, and in particular in one of the entertainment lounges we've been looking at sensory control. They wanted to provide a totally unique, very high-end experience, and we've started to see technologies now that can interface with you to almost fake some sensory control. So that's been a particularly exciting, not to mention some of the biotechnologies where we might be able to artificially, for instance, repair people who might have suffered an injury whilst on a construction site. In terms of autonomous vehicles, This is having a big way that we are looking at master plans and the sorts of spaces that we are providing between buildings. In particular, I love this graphic here from Archipaper, which shows how shared space is going to be used in existing contexts so that it's safer to actually have a set of autonomous vehicles go down there, not to mention all of the benefits around air quality as we move to lower carbon emissions, if that's using electric vehicles, etc., and all of the safety that comes with that. On the 3D printing side of things, this gives our structures folks real potential as to how they can optimize and reduce the amount of materials that are done, not to mention to try new things that we've not been able to do before with our existing materials. If that's learning all of the lessons from biomimicry and the shapes that we have in the natural world or in the human body that give say better compressive strengths, or the ways that they deal with bending moments, it means we're going to be able to do all sorts of new shapes and designs that really push human expression in an artistic sense, but then also in a technological one, for if it's like this bridge being 3D printed to span new gaps. It's about making things that we couldn't before, and also with different materials. If that's a graphene, that's one that Klaus Schwab talks about quite a lot. You know, where we've got different bending moment of area, the I value, what's it called? Second moment of area. There we go. Thanks. Yeah, real potential there. Fourth one that is also affecting some of our design work is the use of autonomous robots. So we've got things like autonomous guided vehicles. If you've ever seen Disney's WALL-E, the little robots with all the fat people on the spaceship roaming around, we are already looking at how we could have services like that in a hotel. If that's picking up towels around the pool, if it's taking out the small bins that you have in your hotel room, or the changing of laundry, or even at hospitals, looking at delivering the right medicines to the right place at the right time. Or what it means for how we design thresholds in structures. If we've got let yourself in drones, let's say you live at the top of the Burj Khalifa and you've got a Deliveroo, the whole process at the moment to get that in through the lifts at the bottom is so much faff that by the time it gets to the top, your food is cold. Instead, we could you know, use a set of let yourself in drones to get it to the right place on your floor. Or maybe we work with robots to get things constructed faster. You know, imagine working with a robot whilst you're painting your living room. That's the robot's responsible for the large surfaces, and then you do the edges. You get things done faster. In terms of planning that, we're seeing that we're moving a lot from BIM now towards digital twins. Working with a company called Willow, which is a Microsoft partner, this picture you can see on the right-hand side is the digital twin of the place that the German lift manufacturer, I can't say it, but you know the one, they're basically building a Willy Wonka lift so that it can go horizontal as well. And yeah, they're able to basically test all that stuff out before putting it into construction. And not to mention all of the benefits that you can have by having a component marketplace, because you know exactly what's in there. I mean, if it works well enough for the International Space Station, imagine the value that we could get out of it for a building. Number 5 is artificial intelligence, and how that we can, you know, start to use the machine learning or even more advanced forms of artificial intelligence to help with our design work. If that's improved parametric design, if that's making our HVAC systems respond to real-time operations and predictions in terms of what's going to happen with the weather, it's yeah, it's a bit of a big deal. I was having a really good conversation with the founder of a company called Placemake.io, and Chalum basically takes all sorts of data around land values, sentiment that's been posted on Twitter, where other businesses are located, in order to predict where would be the most profitable place for you to open your business. It's pretty cool, so I'd check out his website. In addition to that, distributed ledger technologies are going to change the relationships that we have across the whole supply chain in the built environment. It's going to give us real increased transparency, so we know exactly, you know, where the wood has come from, if it's been sustainably sourced. We're going to be able to automate payments so that when we know that the contractor has now finished doing the commissioning on the BMS, which will tell us it's happy with all of its load balancing, etc., we can then start to automate that payment. Or even for ourselves as WSP, when we make particular design decisions, we'll know who and kind of when that happened and the reasons why. On the side of mobile computer and connectivity, we're going to see increased numbers of different types of networks that we have available to us. So there's a lot of talk around 5G at the moment, and that's really good if it's a lot of people on their mobile phones wanting to stream Netflix, or for the latency that you need for autonomous vehicles to speak to each other. But things that are a lot slower and a lot dumber, maybe it's an air quality sensor, maybe it's temperature sensor, those sorts of things need a lot less latency, or rather higher. It's not that they need it, they'll cope. So you can use different sorts of networks, if that's LoRaWAN or narrowband IoT. And we'll start to see the role of where decisions are made in our controls networks change between a kind of 3-place model, if that's on the edge, which is the device can make the decision itself, the fog, which is typically close by or on premise, for things that need fast decisions, and then the cloud for when you need some beefy scale computing that's bringing lots of different things at the decision side of that IoT value chain. In terms of the 9th one around machine learning, I think this is worth going into as a subset of artificial intelligence because of its importance, and it's fairly unapplied in built environment context. So here I've got a picture of Iconics, which I kind of see as an HVAC analytics system, which is able to optimize operations by learning trends and understanding from how a VAV box or a fan coil unit links to the chiller or the boiler in one building and the behavior that we're seeing in another. It means you can have these multi-dimensional interactions that are then able to real-time control the building, trying to get us to that point where the BMS is closer to the human brain because of all of the other external factors that it has access to. In terms of number 10, extended reality. So extended reality is the catch-all term for augmented, which is like the Pokemon Go example, virtual, where you step into something, or mixed, where you blend the two. And they will give us the opportunities to basically help folks with training on site so they can see the data in front of them, or find where that leaking pipe is because it's in the digital twin. They can dial in an expert if it's a bit much for them, and for us to be able to jump into places and test things. And then the 11th technology is around big data and what we can start to learn from it. And I think a really good example here is Nike's flagship store in New York, where they know everything about where the basket abandonment happens online, but not in their physical store. So by having that grid of sensors, we're able to understand how people move, predict those habits, and then start to validate some of the design moves. So to wrap up there, I think some of the issues that we're going to see is around experimentation. Contracting contracts don't really let us experiment, and I think in order to get this technology to be more pervasive and for us to get it right, we're going to have to try things out a bit more. Procurement routes that we've seen from doing this, and in particular in the smart buildings world, makes things very tricky, and we need to kind of shake up how that system's working, particularly here in the UK. There is a huge skills gap around built environment professionals understanding these sorts of technologies. And finally, I see there's a lot of hesitation and reticence out there to implement this kind of thing because there's not enough evidence of the outcomes yet. In the way that Uber has proved that the platform economy and ride sharing works, because you're able to do millions of taxi rides at a global scale every hour, we don't make that many buildings or new cities that often, so we just don't have the same level of outcomes there. So that is the end of my presentation, which I hope has given you a bit of a flavour of some of the challenges that we're seeing around the fourth industrial revolution. And I will hand over now to James Kinch, founder at CrowdThings.
Yeah, absolutely. Thank you very much, Matt. Really, really interesting conversation. Great. All right. So I'm just going to share my screen. If you can just give me a shout when you can see it.
Yep, got it.
Fantastic. Okay, cool. So my talk is going to take a bit of a different tact to the previous two. So in the past two talks, we focused a lot on technology and the individual sort of applications for that technology. And in my talk, I want to focus a little bit more around some of the methodologies associated with how we go about using technology and actually how that can really drive the value that we get from implementing technology in the built environment and sort of like around the places that we live. So the title of my talk is called Platform Economy and the Digital Twin, with the subtitle Disrupting Business Models and for Social Good. And as Matt mentioned, my name is James Kinch and I'm the co-founder of CrowdThings, which is an IoT and smart cities blog. Great. Okay, so when my keyboard works. Ooh. Okay, so to start, I think it's important to point out that I think we're in a bit of a time of transition, and arguably we're always in a time of transition of some form, but in particular, I think we're in one regarding technology. So in the past, we went from a time of not really having a huge amount of technology and really no digital enablement back in sort of like the early 1900s. We then progressed towards a time where we started to develop some kind of digital technology that were very, very application specific. So we started developing sort of like chips and microprocessors and sensors and fairly sort of like computers that would act and be very useful for delivering a specific type of functionality. And so they were typically very, very dedicated towards doing a specific thing. And often they were much better at doing that specific thing than a human was. And that was massively beneficial. And as sort of like time has slowly progressed, we moved from having a few pieces of technology that were very, very like useful for particular applications and started to move towards where we find ourselves now, and increasingly more so, where there are so many different forms of technology that it starts to become a little bit difficult to figure out what we do with all of them. So, I mean, Matt mentioned lots of technologies from blockchain to machine learning, artificial intelligence, VR, XR, autonomous robots, facial recognition, and such like. And while all have a lot of use in a very, very domain-specific way, when we start to think about the built environment, and especially when we start to think about their impact on people, on their day-to-day lives, the question starts to become a little bit more complicated because it's no longer about a technology doing a specific thing. So really where I see we are today is a very technology sort of application focused perspective where we developed a series of technical solutions that are very, very useful and very, very effective. When we think about the fourth industrial revolution, sort of where it is now, and we're seeing a lot of these new technologies being applied in sort of manufacturing and industrial contexts, where they're actually developing and delivering a huge amount of value. So you take a car manufacturing plant, for example, they've applied machine learning, machine vision, autonomous robots, and various other technologies, so that they can basically start to remove the manual labor that's required in assembling a car. That's obviously had a real impact on the efficiency through which we can actually manufacture things, which is, of course, really valuable. But as that technology has started to filter down into sort of more mainstream use, we've suddenly found that actually a lot of the technical solutions and technical applications for technology don't necessarily map to a people solution or a person-oriented sort of solution. And it's really this idea where, okay, well, a technology sort of massively reduces the time to do a particular task, where that stops being so relevant when we're starting to think about like how it might apply to people and especially within a working environment. And so we're seeing this transition towards actually more of a methodology driven perspective in terms of how we actually want to go about using technology. So to dive a little bit deeper, application-driven solutions are typically oriented around questions or statements that are about a piece of technology carrying out a function. So that might be a sensor that can measure a specific thing, or a mobile app that can deliver a certain type of service, or, for example, we hear this a lot from vendors, our analytics system can reduce blah. And these are all well and good, but actually these types of statements never really promote a sense of understanding and never really promote perhaps why we'd want to be implementing a piece of technology in a specific context. And so really the takeaway here is that why never ends up being the focus. Okay, a sensor can measure that particular thing, but why do I want to measure that? Okay, a mobile app can provide a really neat type of service, but is that actually valuable to the people that are going to use it? And okay, your analytics system can give you oversight of how people are moving around a building, but is that really valuable, and do people really want that? So shifting over to that methodology-driven solutions, instead of trying to figure out, or starting with what we know technology can do and trying to figure out a place we can put it, we start with questions that are about what is actually the problem, or how do people want to work, or why does something behave the way it does, and subsequently really putting into focus the why and the reasoning that backs up all of the potential use cases for technology later. And really, this is a holistic methodology. It's about promoting understanding and making sure whenever we implement technology, we're doing it in such a way that it works for the people that are going to be affected by it, and also that it always generates value for the people that are paying for it. So I guess to actually apply that methodology, we sort of have to acknowledge that technology is really all about the data. Technology is only ever a means to an end, and never fundamentally the means itself. And this distills itself into the sense that when we talk about technology, it typically carries out three forms of process, or one of three forms of process. It might collect some form of data. So you think about a sensor collecting information about an environment. Technology then does some processing or some computation in relation to that data. So you think about computers, laptops, mobile phones, they all do some form of processing, and then some form of action, right? And that might be, for example, autonomous robots doing an action that's been programmed into it, or for example, if we have a truly smart building, a HVAC system, that's heating, ventilation, air conditioning, changing its temperature set point based on temperature sensors saying that the room or an environment is too hot. And how this refers back to the methodology is that when we talk about collecting data, we're really trying to create a set of questions, a set of things we want to know, and a set of things that we actually want to understand. So very much being sort of like the why, sort of why focused. Then as we move to that process, it's really about searching for those answers. And actually, we can get lots of answers from data, but it's fundamentally critical that we ask the right questions so that we can then find the right answers to those questions that will actually ultimately lead to that final step, which is actually delivering a set of actions that allow us to solve a particular problem or provide a particular piece of value. So again, really moving away from this idea of a technology does this particular thing, and actually moving towards why it is that we're trying to implement technology, why it is that we want that particular service or system. So again, moving forward a little bit. So we're going to stop talking about individual applications and try and think about some of the systems that enable this kind of methodology, enable this method driven technology perspective. And this is really where platforms and digital twins start to come into the question. So platforms, pretty basically, are data and system aggregators. So they operate a little bit like how a computer operating system perhaps works, where you install software and you provide it data and it does some things and then outputs some things. In any kind of sense, that's what a platform does. So a platform for a building might, for example, take information from a bunch of sensors in that building, subsequently analyze it, change the operating parameters of the building services, and subsequently change the environment within that building. And how this relates to digital twins is so much as digital twins are almost like a variant of a platform, but digital twins are really seeking to go to a next level of detail. They aren't so much about sort of pulling together some disparate systems that might not perhaps be related, but digital twins are more about very accurately representing a physical system. And so we might think about how CAD modeling sort of started in the age of actually defining what buildings looked like, and then we applied building information modeling, where we started to embed further information about the materials and the services going into that building. Digital twins take the next step and actually start to create a fully functional digital representation of that physical system. And the value really starts to be generated when we start to apply an element of action. So we have a lot of data and we have a lot of understanding of a system because we've fully simulated it, we've fully built it, but now we can actually make decisions and deliver solutions straight into the physical world. Breaking this down a little bit further, we've typically seen this evolution of sort of digital systems. And we started with CAD design, where it was all about that physical representation. And then again, as I mentioned, we moved towards BIM, where we started to add additional layers of complexity, additional layers of detail. And after that point, when we really started to think about how that information was genuinely useful, we started to think about, in a built environment context, okay, well, how does that data actually inform the construction of a building? Okay, well, part of that is a BIM model, for example, can generate sort of bill of materials or 2D schematics that don't have to be manually designed. So that's a massive benefit there. But where a digital twin really starts to be embodied is actually we move from that construction phase to actually an operation phase. So we find ourselves with a very, very comprehensive model that actually I could go into that model and understand exactly where people perhaps are within a specific building at any one particular time. I could understand how a fan core unit is operating, whether it's operating sort of at peak efficiency or whether there's perhaps something going wrong there, and actually using that model to manage the building and the environment in real time. And that's really where the power of the idea of a digital twin starts to come into its own, where we start linking that very digital and sort of highly complex and high fidelity model into the physical world and actually making them almost interoperable, where the physical world changes. So, for example, I might change a system in a building. If that change is propagated up to my digital model, and if I wanted to control something in the physical world, I could make that change in the digital model, and that change is propagated down. So jumping to another example, and this is perhaps one that steps a little bit further away from a digital twin and looks towards how platforms more generally are really, really powerful. Taking a look at sort of a property developer, for example, and we're seeing this quite a lot in the real estate market at the moment, where tenants are increasingly coming into the market and expecting very, very different things from their buildings. And I think Paul alluded to this earlier, where we have suddenly very different demands on our buildings. And we're also seeing a lot of changing market conditions, and not least because of COVID, actually. Our buildings are going to have to operate very, very differently. But the environment that this then creates for a property developer, someone who pays for and owns, for the most part, buildings that other people occupy, is that they have to be far more proactive and far more reactive with how they're adapting those environments. And this is really where platforms and digital technology start to come into their own, because really what they're about is allowing that property developer to see changes that are coming to them much, much earlier, so they can predict potentially sort of how tenants are changing their expectations, and then also allows them to be far more agile in terms of how they react to them. And that might look like, oh, a property developer has noticed that a particular tenant has started using their space a lot more intensively, or they're finding that there are a lot more people actually occupying a particular area. And subsequently, the property developer is probably quite reasonable, it's quite reasonable then to think that perhaps that tenant might want more space. And suddenly they can turn around to the tenant and actually have a very informed discussion, because it's data-driven, about how the property developer might be able to provide more space to a way that is going to facilitate that organization to do their jobs better. So again, sort of delivering real value through actually allowing the property developer to be far more agile and actually resilient to changing scenarios. And again, abstracting a little bit further away from a specific building, there is actually a lot of really, really interesting stuff going on with digital twins, especially actually on a national scale. And one particular example is being carried out by the Centre for Digital Built Britain. And if you haven't heard of them and you're interested in digital twins, I definitely recommend checking out their website. There's a reference in the bottom right. And essentially the idea is, across the UK, they're talking about just connecting infrastructure together. And they're going to aggregate this in one big digital twin where all of the data from sort of energy, manufacturing infrastructure and utility infrastructure can sort of be combined. And I mean, besides from the fact that they actually talk about benefits being like per year being realized up to 7 billion, which is really, really quite considerable, they're actually implementing this digital twin using some quite interesting principles. And this is where that idea of social good starts to come in. So we're collecting a huge amount of data that is actually really quite powerful and can really inform our actions and allow us to make very informed decisions with respect to how we change our environment or how we change our cities, but actually doing that in mind of the people that are going to be occupying those buildings and occupying those cities is really important. And so they do everything, so Digitally Built Britain do everything in mind of these 9 Gemini principles, which fall into sort of like these 3 core categories, which are purpose, trust, and function. And you'll see in purpose, the first one there is about being for public good. And that's fundamentally about making sure any kind of technology implementation, any kind of data use is done with people in mind and making sure that it's actually generating value and is done with agreeance of the people that it's going to be affecting. And again, the other aspects there are all about really framing, sort of like making sure that the benefits of that digital twin are actually realized and are benefits that people genuinely want. So just to wrap up, I guess there are 4 key takeaways from this that I'd like to provide. So technology really is about data and not so much about gadgets, and that subsequently shapes the kind of methodology we go about approaching implementing technology. Data actually helps us answer questions, but really picking the right question in the first place is actually the first fundamental step to delivering any kind of value through technology. The real power of data is actually in combining it with lots of other data sources. So it's not good enough to take data from just one sensor. It's much better to take it from lots and lots of different sensors so you get more of a holistic understanding. And then the final one being about platforms, digital twins, is that they offer the ability to not only aggregate data and get that all centralized into one place, but actually that they're really about facilitating analysis and then action on that data. And that is the end of my presentation.
Lovely. Thank you, James. Really, really good. Next up, we've got Christina Goncharov, Smart Places Analyst from WSP, who is going to talk us through a first-of-a-kind fourth industrial revolution city. Are you able to fire your slides up, Christina?
Yes. Just...
Lovely. Got it. Take it away.
Got it. Brilliant. Okay, so my name is Christina Goncharov. As Matt had mentioned, I am a Smart Places Analyst at WSP. And for the past few months, I've been working on the strategy for the first of its kind for IR City. And after going through that process, I guess there are a few things that I'd like to share with you today in terms of the key concepts and what we consider to be revolutionary concepts when it comes to the approach of urban master planning. So to give you some context, the fourth industrial revolution has had some precedents. The first being steam mechanics, and we can see all sorts of urbanization projects picking up speed here. We can see things like factories starting to pick up speed. In the UK, one of the biggest items for that period was the building of canals. By the Industrial Revolution 2.0, we can see mass production happening around the world. Railways are being built due to new opportunities with steel. We can see automobiles and more so electricity coming about in the city. By 3.0, we already have what we now know as the digital era. So that's the development of computers, electronics, and digital communications. And I guess where we're sort of sitting at today is Industry 4.0, and that's looking at the actual connectivity of these electronics and digital communications. And of course, 5.0, we don't know yet, but we have a small assumption that it will be to do with cognition and understanding the cognitive city. And that is the point when these new connected electronics actually take on their own mindset. So what does 4IR mean for the city? Well, working on it, we can see that actually 3 things really stand out. The first one being that there are new users, the second being new communication mediums, and the third being new structures, new service structures, sorry. When we're looking at new users, we're talking about and thinking about who we're designing for. When we're looking at communication mediums, we're looking at what infrastructure is required and how these different components interact with each other. And we're looking at new service structures, we're looking at new hierarchies and new streamlined systems and systems, yes. So to break down the new users, what do I mean by this? Well, in a traditional city and in most cities up until now, everything that we have been designing ultimately leads to a human-centric user. So roads have been built, yes, for vehicles to drive upon them, but mainly so that the human can move from A to B. In the 4IR city, we can see these three new users who end up taking a pretty much a similar role to what humans would usually have had in the city. The first one being materials. Why are these similar to humans? Well, we can see that in the fourth industrial revolution city, materials now have passports. It is just as important to track where materials have been, what they are included in and where they are going to go, just as important as it is to have international borders and to make sure that we register correctly when we're moving from across state lines. Devices now have healthcare. Just as important as humans, we need to make sure that devices are healthy, they're working correctly. And in the new 4IR city, we have systems that work around the clock to make sure in real time, to make sure that all our devices are healthy, happy, and working at their best. And the third being freight. Freight now takes on an equal role, shall we say, in terms of moving around the city. If before, as I was saying, roads were being built for humans to move from A to B, now freight has just as an important role on the roads and has equal opportunity to move around. New communication mediums. Now, this is the second concept. And by new communication mediums, I don't necessarily mean that these mediums are brand new. However, they're brand new as a citywide standard. At the moment, of course, we have been through the digital era. So we understand that we do have some types of digital communication. We have fiber connections, we have Wi-Fi, we have the sort of lower latency and longer distance LPWAN. But for the 4IR city, these must be enhanced. These need to be working twice as hard. We need to have more nodes and more connections, more access points. We do need also some new infrastructure. As we have heard before, 5G is very prevalent. It is a revolutionary network communication. It allows autonomous vehicles to work pretty smoothly, shall we say. It does allow for a lot of other data transfer to happen, so it is quite a key player now in the city. Again, for that to happen, we need to be able to have better fiber connections to power the 5G nodes, which then allow us to use this network. Another new network we will see as a standard within the city is Zigbee. Zigbee allows you, and it allows for smaller distance and for smaller quantities, shall we say, of data to move around. And these are more useful for maybe pieces of urban infrastructure, some urban furniture, items that are close proximity to large-scale buildings that can feed off their Zigbee networks, for example. And Bluetooth. Bluetooth has been around for a very long time, but we do see the need to start building in new Bluetooth beacons in public spaces and in the urban environment, rather than just within buildings. New service structure. Now, what do I mean by this? So all of these new users and new components need to interact somehow and need to be managed somehow. So this IoT stack framework is an industry standard at the moment in terms of looking at how these new users and components interact with each other. And if we start at the top of the hierarchy, we can see that we have end users. Now, this used to just be a human. Now we differentiate between city dwellers and operators. City dwellers being those who receive, let's say, the front end of different applications and services, and those who directly interact to receive some kind of output. The operators are there to maintain and to overlook the entire system. So they obviously need to have slightly different visuals and interactive capabilities with the digital systems that we're building. The next layer being the UI and UX. So this is just looking at the interfaces that we use to interact with all of these digital systems. These can be a range of dashboards, screens, your mobile phone, your smartwatch. These all fall into this category. So what are the actual things, shall we say, that allow you to
Can't hear. Hello?
Yeah, I don't think that's. Oh. Christina, I think you've just gone on mute.
Oh no, tech crisis. We can see your screen.
Hello?
There we
Hey.
go, you're back.
Hello, I have no idea what has happened. Apologies. Hear me now. Where did you lose me? Right, okay. So the dashboards, as I was saying, is the mobile interfaces. So it's how you actually see this data. The services layer is the data analytics, which allows you to pass, shall we say, the information that is coming through. And on a day-to-day basis, we see this as your applications on your mobile phones, all sorts of machine learning and AI services that we can see. Your IoT platform layer is then looking at where all of these different services and sensors, where it's all consolidated. So more typically, we can relate to things like OS systems and databases. And it really is this consolidation layer, which can be seen as the cloud, for example, or as different fog layers in the city. Next, the network layer. As we briefly discussed earlier, these are the ways of communicating and the different mediums that the sensors and devices use to communicate. And the final layer is our devices layer. And these are the actual sensors themselves. And as we can see, what seems to be quite a logical and clear framework can actually be quite complex. So why would we call this a digital ecosystem? Well, in a nutshell, that relatively clear framework looks like this in terms of a city. But it's much more complex. Each sensor can have a range of different communication methods. Devices can have preferable communication methods. Each sensor can be connected to different services and can be thread through different platforms. So just to run through how this relates to the IoT stack, in this first column, we can see that this is our devices layer. So these are looking at all sorts of different sensors we have within a city, be that your PIR sensors for motion and occupancy control, be that your soil sensors within urban parks, be that your air quality, your water meter, power meters, those types of things. Then we have the network layer, which follows after. And we can see that predominantly in the 4IR city, 5G really is our main player for communications. We can then see the LoRaWANs coming next. These allow for a more regional analysis, more so than interurban, but also just as important. And then you can see the rest following after, like your Wi-Fi, your fiber, your Bluetooth. Next is our platform layer. So these are all sorts of different OS systems that will be running within the city. It could be your weather station, your utilities platform, looking at mobility and managing autonomous vehicles. They now sit within their own platform. And then the services layer, almost as large as our devices layer, understanding which services require which data and which platforms they should be linked to in order to get those specific data points. Sometimes we see that there are multiple platforms within one service, so the whole system does get a little bit more advanced. And now the UI and UX layer. These, as I was mentioning, are your different types of dashboards and mobile phones. Within the city, we can see there's a very large range of different opportunities and different moments where we need to show siloed data. That could be some interactive screens on the main city square, or it could be some emergency service pylons that are spread along streets. It could be a wayfinding pylon that allows you to book a car, or find out some more information about the world around you and maybe offer you a new route to walk down. And then at the end, you have your end user. Now, the main difference between the fourth industrial revolution and how we build for that in the city and previously, as I was saying, are these new users and new communication methods and new services. But actually, one of the biggest differences and one of the most revolutionary points that we are at within the city and urban planning is the fact that we have these new users on the far left. And we're no longer designing just for human-centric needs and requirements. We are also designing for non-human needs and requirements. If you take a smart factory, for example, there are no longer human workers on the shop floor. There are now large-scale machinery with tens of different sensors and services placed on top of them in order for them to execute their day-to-day job. As I was mentioning before, these new users need healthcare services. They need agreement to be working in a specific area. So we can actually see that now when we're looking at developing the city, we need to be looking at equally at both ends of the scale and no longer just at the right hand side as the human end user. Thank you. In a nutshell,
thank you very much.
That is my presentation.
Well, Matt, I think you're going to be required in answering questions a lot. So, so far, Christina, that was really fascinating. Non-humans and humans. Well, that's really, really exciting. It triggers the imagination. We do have some questions online, so I'll start from the most recent one first. And Shahid asks, what do you see as the biggest stumbling blocks to the adoption of 4IR?
Yeah, I think it's probably people. I think the business cases are there in lots of these technologies, albeit emerging, and so it will be the trust of it. I think when we think about some of the AI stuff, there's a big component around ethics with that. I don't know, James or Philip, have you got a view on it?
I think you're right. I think that the people component is going to be probably one of the most critical. Obviously, there is a technical challenge in we're dealing with not just sizes of data that we've never seen before, but forms of data that are telling us things we don't even really understand yet. So I think there's a technical challenge there. But no, I'd agree. I think it's the people at the heart of it.
Right. Another question from Jacob. How could one overcome the obstacle are facility management not willing to share operational data with designers?
With your contract.
Yes.
Yeah, I think it's an interesting one because they've obviously got their own KPIs to meet. And if I think about a building that's has a lot of this technology already enabled, you're basically making their job easier for them. So I suppose the challenge is who owns that data firstly, and as to who installed it is normally the one that gets to keep it. And then it's what they're willing to share. But I think if you're in a situation where you can't have that conversation with your facility manager, then it's time to get a new one.
Could I ask a question, Matt? You used the phrase augment the human. And how far can we go? Are we going to remain as human beings as we know it? Or are we going to become one day more of a cyborg? I'm thinking that you can embed sensors in clothing, you can embed sensors in the body. So how do you envisage the more distant future from the human point of view? Are we going to change kind of form?
You know what? I think so. I think we're going to start doing more and more stuff if that's implantables. Like I've seen someone from my friendship group who's had a chip embedded into their hand so they can like load their tube card and stuff onto it. Yes. I suppose in the same way we wear glasses or that we have crowns put on our teeth, that's a form of augmentation. So I think we'll just see more complicated versions of it.
Right. Anyone else like to say anything about that? Right. Okay. We have another question from Terence. How can the industry ensure standards across smart cities and buildings? For example, we don't want to end up with proprietary apps, standards and technologies from building to building and city to city, he says.
I think
that's a good James question.
Yeah, I mean, I think there are a couple of thoughts there. One would be the intrinsic nature of like the fourth industrial revolution and platforms is that it's going to involve an awful lot of people, a lot of different use cases, and it will probably be very difficult for any one company to establish such a monopoly over absolutely everything that their way of doing things would be seen as the only way of doing things. So I think there's that acting against it. But from an everyday, like practical project side of things, I would argue that you need to approach everything like from the word go, like before you even start considering the technology from the place of just trying to keep it open and try not just from like a technology perspective, but like a data and a methodology perspective. You've got to go into that wanting to share it and wanting others to participate in it, and especially wanting the users to participate in it, and which I think is a key part of that.
Well, I mean, what I've picked up from the 4 presentations this afternoon is that although there's a lot of high technology involved, there's also a desire to satisfy the human and social requirements. And this brings into mind another question from Shahid, slightly tricky one, without getting political, so if we could put that to one side. What are your thoughts on the involvement of Huawei with the UK's 5G role from a security point of view? And I would like to add something else to that. I don't know how strong the evidence is, and some of you will be able to tell me. There has been some questions about health risks with 5G. Now, this may be rumor and may not have any substantial foundation, but if you could add that point into what Shahid has asked about security, he's asked about, I'm asking about health. Any ideas?
I guess I'll jump in there one.
Christina?
Yeah, Christina, do you wanna
Well, the question of health and 5G has been slightly left to the side in terms of master planning stages that I've been involved with, just because the pure necessity we have at the moment for these cities to operate. Without 5G at the moment, these things wouldn't be possible.
Okay. Matt, any further thoughts?
It's difficult without making it political, isn't it?
Yeah.
Yeah.
Yes. And Phil, I don't know if Phil's still with us. He may have left. Right. Well, those are all the questions on the chat side. So now it's open to anyone who would like to add some further points, some experience perhaps of using some of these things, or the presenters themselves. We can ask each other's questions. So just chip in.
Hi, can you hear me?
Yes. Who is that?
Hi, my name's Tony Bignold.
Right. Okay.
In FM. I'm going to come across a little bit negative, but I'm not. I'm actually a really big advocate of this. But I've been, I suppose, I've been in industry a while now. I've yet to see a decent set of O&M manuals, and I speak as I was once an M&E contractor and was delivering these things. And I see a huge challenge in changing the culture, and almost ethics might be too strong a word, but the digital twin and BIM models, they're going to get devalued very rapidly unless we can change customers, contractors and FMers, because FMers aren't good at maintaining them, customers don't see the value. I'm not sure there's an answer. It's just really I see it as a significant risk and challenge, and how that's overcome sort of through the design and build phase. It's probably that's where it needs to be addressed rather than at the end of completion of a building.
Yeah, if I could just
exactly.
On that.
No, go for it, James.
I was just going to say that that's a really salient point, and I would argue actually. One of the biggest problems I think smart buildings have faced, especially from like a maintenance and facilities perspective, is that FM wasn't considered as one of the users when they were defining these systems. Like it was only ever like user-centered design was only thought of the people, like the occupants within the building, and actually probably one of the most key users of systems like that are those that are going to maintain them and operate them for others, which I think were we to shift towards a perspective that took of like considerations like ease of maintenance, like how could we make it easier to update sort of like a BIM or a digital model, and how do we upskill facilities management? If we made those central questions, we'd probably go a long way to solving a lot of these problems of like almost like redundancy of digital systems.
Yeah, can I just ask our questioner there about robotic maintenance? Is there any strong move towards robotic maintenance?
I've not heard of any robotic maintenance. There's sort of condition-based maintenance where people are monitoring systems. So rather than it being periodic, it's when equipment goes out of calibration rather than turning up every month. So there's lots of that going on, sort of condition-based maintenance. But I've seen robots in hospitals, so moving equipment around hospitals before, but that's more supporting the clinical side than the pure maintenance side. BIM models are coming through, so yes, maintenance people are having to use BIM models. But again, I see the huge benefit of BIM models is the digitalisation of the O&Ms, so staff can get real-time access. Hence my concern about them losing their data quality over time, rather than where a piece of equipment is, because unless you're working in a massive building, engineers should know where a piece of equipment is and sort of be able to pick it up from screens and handhelds rather than wayfinding through a mobile phone. So real-time access to quality data, the relevant quality data, is where I see the huge benefit for maintenance staff.
Okay, now I see that Stephen Hipwell. Stephen Hipwell's got a hand up. Stephen?
Hi, Derek.
You got your hand up.
Yeah.
Do you want to ask a question?
Yeah.
Good.
So you asked for some some feedback on, say, 5G. So we're in the process of designing a building at the moment. So I work for a university in Birmingham, and one of the conversations that we're having is how we can make the university building 5G ready, and what that actually means. So from previous experience, some time back, putting mobile boosters into buildings and falling foul with Ofcom, we're quite reticent about how we approach it, and also the application of 5G. So the basic principle that the way we're approaching it at the moment is that we'll use Wi-Fi 6 and Wi-Fi within the building to service the building, and then we'll use we'll basically be using 5G external to the building to get around any attenuation issues and anything like that. So I think 5G will become much more important as it's rolled out and deployed, especially in the major cities. But Wi-Fi 6 internal to buildings is still the preference. We think. Happy to be corrected on any of that.
Just to add to everyone that Stephen is planning a webinar on his work at the Birmingham City University. And so we'll be hearing more about that. But just coming back to what you've just said about the slight cautious way of using 5G, does any of the speakers want to come back on that? I don't know, Christina, you were saying that's the way we would be going. I suppose we will be, but any comments at all?
Yeah, so as I was saying, 5G is really important, especially for the city when it comes to autonomous vehicles. At the moment, we really don't have another way to get so much data across at such a short speed. It is possible to use alternatives, and where possible, we have pushed for those when looking at developing the city. But as I was saying, it really does come down to the opportunities that 5G does bring and the differences that communication medium has, I guess, against its alternatives.
All right, thank you. Now, Jin Roy, you had your hand up. Jin?
Yes, yes, can you hear me now?
Would you like to ask a question?
Yes, my question is, I'm actually very impressed, and it's great insight to hear James talking about from the application-based approach to the methodology-driven. I assume it's more like human-centered or based on the human needs. Somehow that reminds me of the pure technical to the social technical concept. But when I listen to the Christina's presentation, is moving from just human-centered to also other like machinery or sensor. So my question is, when I compare the two presentations, are the 2 points agreeing with each other, or there are some differences, or my understanding is not right?
I think it's very perceptive, like the observation. I think actually the two places that we came from are fundamentally linked in so much as you'd start off with almost like the user-centered component of design, thinking about the methodology first, the stuff I talked about, and then once you actually established why you were doing a lot of the things and the perhaps the technologies that were relevant, that's immediately when you almost step directly into what like the perspective Christina was talking about, which then starts to think about, okay, well, how do we actually deliver the value through this technology?
Yeah, exactly. I agree with James on that point. I agree. And I guess the difference that you saw between our two presentations is just where James is highlighting the importance for the human-centric, and where I've mentioned that now we have this new non-human user that is equally as important. So I'm not saying that it's any less important to be doing designing human-centric systems, but it is also as equally as important nowadays to be designing for a non-human user, which is not something that we really have seen prior to this point.
Okay. Now we have a question from Kai Zhu. Is 4AR very different from initiatives such as Smart City? Kai, do you want to say something about that? Kai Zhu? Sue? Maybe he's...
Hello?
Are you, hello, Kai,
Yeah,
are you with us?
Myself. Yeah.
Right, okay. Would you like to amplify what you mean a little bit more by that question?
Okay, so I have a computer science background, and so to me, smart city is something I'm more familiar with. And, so to me, it seems the smart city also use lots of sensors. They try to analyze data, and which certainly has overlaps with the fourth industrial revolution, especially when you're applying all these sensors and data analytics inside the building, for example. So I just want to see, is the two very similar, has lots of overlap, or quite different in what kind of perspective?
If I could respond to that question.
Sure.
Yeah, so I wouldn't say that they're very different. They most certainly do have a lot of overlap. I would say the main difference is smart cities up until this point have been either built previously, so they are traditional cities that have been made smart through certain enhancements, shall we say. And in general, we do also see smart cities being built around the world. But the difference between a traditional smart city and a city built based on the fourth industrial revolution is that in the 4IR city, we're actually building to support the fifth revolution. And it's this notion of cognition and how do we support a city that now thinks for itself. So smart cities predominantly, yes, we do have, say, AI systems and services within a city. We do have the sensors and we do have those communication channels, but it's just taking it to that next level. And when you're building it from scratch, it's actually understanding what is that next level, what is the fifth revolution, and how we yes.
Yes. I mean, hello. Are you still speaking, Christina? Hello.
Yes. No. Hello. I'm here.
Your voice has gone. Do you want to add some more points? Are you finished? No. Right. Okay. I was just thinking that as you were speaking there, I mean, if we take the autonomous car, I mean, without the human driving, although there would be a human present, I suppose. I mean, things, whether they're human or non-human, they still go through the same processes of like birth, maturation, care, commissioning. All of those processes still apply, don't they? And so I guess what Christina has described, I can kind of see as things become more automated and so on, there will be a bigger demand on a less human workforce, maybe in some areas, but the machines will still be extremely important. Now, I think, Jin, we've answered your points about the agreement between Christina, that you've got it down again, but I think we've resolved that. So now we're into the final 4 minutes. Matt, you've been such a great co-moderator with me this afternoon and brought us 3 marvelous presentations after the one that we had from Ross. Would you like to sum up your feelings of the afternoon? Hello?
I have a feeling
Matt?
Matt
Hello?
Matt left us.
He's left us.
I think his internet may have cut out.
Yeah.
Oh, right. Well, okay, that's a pity, but still, James, any thoughts about the afternoon?
Yeah, I think what all of these presentations have shown is actually almost very, very nicely as we've progressed from Paul's first talk and straight through to Christina's, we've almost gone full cycle of looking very much at the context behind Fourth Industrial Revolution, then looking to a lot of the technologies, and then I focused on the methodologies, and then actually jumping almost to the next generation of technology and how those all are strung together in a city. And I feel like with the discussion we've had, we've actually almost alluded to this idea that it's a very, very, it's not like a linear process for doing smart or doing the Fourth Industrial Revolution. It's actually a very interwoven web of different technologies and different thinking and different methodologies that ultimately sort of knit together this sort of broad-based industrial revolution.
Yes, absolutely. Christina, anything, a summary from your feelings this afternoon?
Well, yeah, as James was saying, it is really nice to have seen the presentations, I guess, in that order as well, where we started with the smaller scale and more so the side of smart that most of us find easier maybe to relate to in the current environment. Smart buildings are very crucial at the moment at getting people back to work. So starting with the understanding of the smaller scale, the individual building itself, then the higher impact it has on society, and as James was talking about, social good and more social benefits, shall we say. And then myself having the opportunity to speak about the entire city as a whole. I think it's a very nice way and a very holistic afternoon to have listened to, for sure. So it's a great pleasure to present with you guys.
Well, thank you to all of our presenters this afternoon, to Matt, to James, to Phil, who has left us earlier, and Christina. Now, I would just like, before we go, to mention, first of all, our next webinar will be the 23rd of September, when we'll be discussing the zero carbon debate. And on the 7th of October, we're linking up with Harvard University in America on workplace research. I should add, we're also linking in with the new transdisciplinary workplace research group, which originated in Eindhoven in the Netherlands, and I'm part of that too. So those are our next two meetings. I would also like to invite you all this afternoon, the presenters, to consider not putting too much work on you, but it would be very nice. We have a journal, Intelligent Buildings International, and it would be very nice if any of you, all of you, but if some of you at least would like to offer a paper into that journal, I think it really would be good. If you all got together, then we could have a special issue devoted to this area we've been talking about. If only one or two of you, well, we could do it separately. So please write to me and let me know your feelings about that. And with that, I'm going to say goodbye to everyone. Thank you to our audience, which to over 80 people and is now 40, even now it's 44, nearly 50 people. So thank you to you all for joining in this afternoon. Thank you to our presenters, and look forward to seeing you all again. Bye-bye.
Thank you very much.
Thank you all. Thank you.
Bye-bye.
Bye-bye.